Welcome to the video for Maths 1.2, Finding Arithmetic Means. So you'll be used to doing averages from maths, and you'll know there's more than one type of average, but in chemistry all we're interested in is means, and finding the mean of a set of data. So to find the mean, all you do is add up all the points that you've been given, and then divide by the total number of numbers in that list. So, for example, if we had 1, 4, 4, 4, 2, 9, and 4, to find the arithmetic mean of that set of data, you simply add them all together, which gives us 28. And then there are 7 different numbers there. So you divide the 28 by 7, which gives 4. So the mean of those 7 numbers is 4. It's very important that the mean is recorded to the same number of decimal places or significant figures as the original data. So especially when you're doing recording experimental results, the mean, so for example in titrations, if in your titration if you have only recorded it to 1 decimal place, then your average should only be recorded to 1 decimal place. The other thing about experimental data is if it's experimental data, normally would exclude any anomalies. So in a titration you quite often get anomalies. So if you have the following data of 25.1, 24.6, 24.5 and 24.5, then the 25.1 is clearly an anomaly and therefore should be excluded when we calculate the mean. So you would only to calculate the mean of those 4 figures, you would exclude 25.1, you'd add 24.6 plus 24.5 24.5 and divide by 3, remembering that you have to only record it to 1 decimal place. A slightly more complicated example of arithmetic means is something called weighted means. So sometimes you'll be asked to calculate the weighted mean, which is where some values are given more weight or more value than others when the average is calculated. So to work out a weighted mean, it's the sum of the value times by the weight. So it's each value times by the weight of that value, and then divide that by the sum of all the weights. So it's how many different weights there are. It's best with weighted means to show you an example rather than trying to explain what you do. So, the example we're going to think about is Simon wants to buy a chemistry revision guide to help him with A-level chemistry. He looks at all 3 guides and he rates them out of 10 for each of these categories. So he looks at textbook A, B and C. You've got cost, clearness of diagrams, number of example questions, clearness of writing. And they're the 4 things that are important to him. So he goes through and he rates textbook A, textbook B, textbook C on all of those 4 things. And if he works out the normal mean of those items, then textbook A comes out at 6.75, textbook B comes out at 5.25, and textbook C comes out at 6.75. Now you'll notice I've gone against what I said before here, because actually they should be recorded to the same number of significant figures or decimal places as the original, so it should really be 7, 5 and 7. So if going on this crude analysis, if Simon was to look at his textbook, he would think that either A or C were the ones that he should buy. However, when Simon thinks about it a bit more carefully, he thinks that some of these factors are more important than others. So what he thinks about is that actually the cost isn't that important, and what's more important is the clearness of the writing and the number of example questions, because that's what's going to help him improve. So he gives a factor percentage of importance. So cost is 10%, number of example questions is 30%, clearness of writing is 40%, and the remaining 20% is diagrams. So now that he's got this idea of a weighted giving a weight to the values, he can calculate a weighted average. So this table looks horribly complicated, but it's quite straightforward. So in the left-hand column you've got each factor, and there's a percentage of each cost. And then if we just look at the textbook A column, So textbook A, the cost has a rating of 5, but the cost has a 10% weighting. So what we need to do is calculate the weight times by the value. So it's going to be 50 because that's 10%. So it's a percentage times by the rating, so it's 10% times 5 is 50. The clearness of the diagrams, we decided that would work 20%. So it's then 6 times 20, which is 120. The number of example questions is 30%, so 9 times 30% is 270. And the clearness of writing had the highest weighting of 40%, so 7 times 40 is 280. Add all of these together, it gives you 720. And then you need to divide it by the sum of all the weights, which in this case, because it's a percentage, comes up to 100. So it's 720 divided by 100, sorry, which gives you 7.2. So our weighted average is 7.2. So it does the same for textbook B, and it does the same for textbook C. And now you can see that there's a different order. Textbook A has clearly come out on top of 7.2. Textbook B is 5.9, and textbook C, which was equal to textbook A when we did the normal mean, you can see is actually the worst one.